as we look at constant acceleration. And the next really applicable version of constant acceleration is the idea of free fall. So when something is falling, what we can ask is something simple. This is an old question: which would fall faster, a hammer or a feather? And if you look at that, Aristotle would say that it was the hammer because it has more mass and it's returning to its natural state. Galileo reasoned that if you were on the moon or somewhere where there wasn't any air, they would fall at the same rate. It has nothing to do with the mass, it's just the pull from the Earth. He didn't really think of it as a pull from the Earth, he just knew there was something that caused it to accelerate downwards. So he came up with a fairly simple experiment. The one you hear about in pop culture and see sometimes even in textbooks is the idea he went up on top of the Leaning Tower of Pisa and dropped different weight objects and saw that they would fall at the same rate. Turns out that that's not true. What he did was a little bit simpler, and it's a little bit better experiment actually. What he did is he took ramps and had different mass objects and looked at how they rolled at different times going down the same ramp. So if you look here, you can kind of see this is kind of like our video capture, but you can see the heavier ball and the lighter ball at different times are at the same point on this ramp rolling down. So what he figured out is that the acceleration due to gravity, not the pull of gravity or not the force from gravity or nothing like that, was a constant. It was the acceleration that it caused. Sometimes that's called the gravitational field. The pull from the Earth is a constant, and we give that constant a symbol. It's a lowercase g, the acceleration due to gravity, and that's on the Earth, it's about 9.81 meters per second squared. It's different in different places depending on your altitude, depending on local density and things like that. So a lot of times we'll just use 9.8 meters per second squared in most cases, just to be a little more general. A lot of times, especially in the AP curriculum, they'll just use 10, which for most cases is close enough. But it's always going to be downwards. It's always going to be pointing down, and it's what we can use. It's the nice thing. All we have to do is for all of our equations of motion, we just use that g, that 9.81 or 9.8 meters per second squared in the negative direction.